Good morning, everybody. I was just sitting here thinking to myself, you know what? It would be great to talk about the law of sines. And so that's what we're going to do. The law of sines is a pretty cool thing made for dealing with non-right triangles. And that's one of the keys here, is that we've been working with right triangles a lot over the past several weeks. And there are some things that we don't want to be restricted on our angles for. And so we're going to talk about what we can do when we have a triangle that's not a right triangle. So let's say that we have a triangle that we don't know is a right triangle. I'm going to make it look sort of like this. And I wanted to find out information about this triangle. Unfortunately, I don't have any right angles. Let's go through and say that we have angle A, angle B, and angle C, and side A, side B, and side C. Well, unfortunately, I can't use sine, cosine, or tangent in this thing because, as I said, this is not a right triangle. This is not a right angle. This is not a right angle. This is not a right angle. So what we're going to do is we're going to get creative, and we're going to draw a line that is perpendicular to our base AC so that it makes a right angle. And we're going to call this value H right here. You might say, what is the point of doing that? Well, by creating this thing, I've actually made two right triangles inside my non-right triangle. And I did this with an acute angle, but this could just as easily be an obtuse angle. It doesn't really matter what B is or what C is if I wanted to call AB the base. But if I had this thing, then I could say that the sine of angle A is equal to my opposite side over my hypotenuse. That would be H over C. And that's pretty straightforward information. We know that that is generally going to be true. I could also say that the sine of angle, sine is spelled with an S, there we go, of angle C is equal to H over A, because this is my opposite side, this is my hypotenuse within this tiny little triangle right here. And both of these pieces of information have to be true. We know them to be true. Well, I could do some manipulation of this first equation, and I could say that C multiplied by the sine of angle A is equal to H. And I could say that A is multiplied by the sine of C is equal to H. And if this is true, well, this H value is this H value. They're the same thing. And so if they're the same thing, then C sine of A has to equal A sine of C. So we could then write that C multiplied by the sine of A is equal to A multiplied by the sine of C. And once I have that, if I wanted to, I could say divide both sides by the sine of C and divide both sides by the sine of A. If I divided both sides by the sine of C, those cancel. And if I divided both sides by the sine of A, those would cancel. And so I would end up with C divided by the sine of C is equal to A divided by the sine of A. And this is part of our law of sines. And for what it's worth, as I said before, we called this side B our base, but I could just as easily call side C my base, in which case I might have had a height coming through this way. And I could have made the same relationship using angle B and angle A as I did with angle A and angle C. And so that's going to mean eventually that this is also equal to B divided by the sine of B. And this thing right here is your law of sines. And it basically says that in any triangle, the ratio that's created by a side and the sine of an angle opposite it is equal to the ratio created by any other side and the sine of an angle opposite it within that triangle. And some people will write it this way. Some people will write it with the signs on top. So we have the sine of A over A equals the sine of B over B equals the sine of C over C. This is a personal preference thing. It does not matter which format you use. They'll both work. So do whichever one makes your heart warm and fuzzy, and you'll be okay. And what this allows us to do is solve any non-right triangle as long as we need an angle and its opposing side meaning that if we have angle C, we need side C. If we have angle A, we need side A. And we also need and one other piece of information. It can be a side length, it can be an angle length, whatever you want. My dog came to say hello. Hi, Poppy. Yeah, you're a good dog. You're a good dog. That's Poppy. That's Poppy's bed. Very exciting stuff. All right. So there are some different formats for triangles where we can use the law of sines. One would be if we know an angle followed by an angle followed by a side consecutively. One would be if we had an angle followed by a side followed by an angle consecutively. Those are abbreviated angle, side, and angle, side, angle. Those are the simpler situations, so we're going to deal with one of those here. So let's say that we have a triangle EFG where we know that E is equal to 4.56, angle E is equal to 43 degrees, and we know that angle G is equal to 57 degrees. Now, if I'm dealing with a problem like this, the first thing I'm going to do is draw a picture of this situation. Note, my picture does not have to be drawn to scale. I just do this to sort of keep track of where things are. So if I call this E, F, G, then this is side E, side F, and side G. So this would be 4.56, this would be 43 degrees, and this would be 57 degrees. Now, what I note is that I do have an angle and the side opposite it, and I have one other piece of information, which means that the first thing that I'm going to do is find side G. So I could go through and I could say that the sine of 43 degrees over 4.56 is equal to the sine of 57 degrees, that's G, over side G. And this isn't too bad. I can solve this pretty easily. G would end up equaling, if I multiplied to get G over on the left-hand side, I'd have the sine of 57 degrees multiplied by 4.56 divided by the sine of 43 degrees. Nothing too tricky there. And so if I went through and I did that using my calculator, I could find out that side G is equal to 5.61. Now, that lets me know that I know this piece of information, this piece of information, this piece, and this piece, but I don't know anything about F. But I do know that this is a triangle, and because it's a triangle, the three angles have to add up to 180 degrees. So if this is 43 degrees and this is 57 degrees, then I know that angle F has to equal 80 degrees because the three angles add up to 180 degrees in any triangle, which means that the thing that I just did with sine of 43 over 4.56, I can do over again. So I have the sine of 43 over 4.56 equals the sine of 80 degrees over side f. Once again, that would mean that f equals 4.56 times the sine of 80 degrees divided by the sine of 43 degrees. And that's something that's pretty easy to solve. I find out that f is equal to 6.58 units. So I just write in that f equals 6.58. I've now got every piece of information about this triangle. I know what all three angles are. I know what all three sides are. So this triangle is now considered to be solved, and I am finished with the problem. So that's how we deal with the basic problems dealing with law of sines, dealing with angle, side, and angle, side, angle. There's another situation, which is going to be side, side angle. And we'll talk about that in the next video. Side, side angle creates some issues because it can create something called an ambiguous case, which will produce potentially two different solutions. So we'll talk about how to deal with that during our next video. Hopefully that was helpful and you learned something. So again, law of sines used for non-right triangles, though it would work for a right triangle, but we just don't bother. It's easier to just use sine, cosine, or tangent. And that's how we do it. I hope y'all are having a lovely day, and I'll talk to y'all soon. Have a good one. Bye.